we had some extremely exciting discoveries just last week. So we had taken uh, a group of our test ARK crystals to an independent lab, uh, and we were able to, with them, perform measurements of photon emission from the ARK crystals. So this is something rather unusual to look at for a passive device, because or a passive object, right? It's a crystal. You wouldn't really expect it to be emitting photons unless it was absorbing energy from somewhere. So this is a walk-in Faraday cage. It's a completely EM shielded environment. So all ambient electromagnetism is blocked within this chamber. And within the chamber, there's a photo detector. So the ARK crystal has 3 axes, as does everything in a 3-dimensional reality. Now, because it's a crystal, each of the axes have different properties because of the breaking of spatial symmetry by the crystalline lattice. So in one orientation, you have the z-axis, pictured on the right. That is the optical axis. It polarizes light. It's also birefringent for both light and sound. However, at a 90-degree angle to that, there's the x-axis, and that's depicted by the left-hand image here. Now, this axis is called also the electromechanical axis, or the electrical axis, and it's piezoelectric. So if there's compression, that is mechanical energy, along the x-axis, it will generate an electrical current. And conversely, if there's an electrical current, it'll cause acoustic oscillations of the crystal. So we tested different orientations, and what we found was that there was a significant increase in the number of photons being emitted from the vertices, the points of the tetrahedron. There is a astoundingly high amount of photon emission occurring from these points. At least from a conventional perspective, there's an unexplained emission of energy from the crystals that is continuous.